Hello, let's continue on with some advanced differentiation. Today we're going to talk about the chain rule. Okay, so essentially what the chain rule says is if you have a composite function, so a function composition where there's one function inside another function, to take the derivative, you take the derivative of the outer function and leave the inner function alone for the composition, and then take the derivative of that inside function and multiply at the end. Okay, makes more sense when you actually see it, so let's go ahead and do some problems. Okay, so in this problem we have cosine, which is our outer function, and then we have x to the third, which is our inner function. So what we're going to do is we're going to start by taking the derivative of our outer function, which is going to give us negative sine. And when we do that, the inner function stays the same. Okay, so the derivative of cosine is negative sine. Keep that x to the third the same for right now. And then deal with that x to the third. So the derivative of x to the third is 3x squared. What we're going to do then is just kind of simplify this so it's written a little bit more neatly. So we have negative 3x squared times sine of x to the third. Okay, and that's the chain rule. Let's do another one. Outer function is going to be this 1/2 power. The inner function is going to be the x to the fourth plus 1. So we're going to deal with the outer function first. So y prime equals, multiply by the exponent, keep the inner part the same, and then subtract 1 from the exponent, and then multiply by the derivative of the inner function. So the derivative of x to the fourth is 4x to the third, and the derivative of 1 is 0. So now I can simplify this. 1/2 of 4 is going to give me 2x to the third times x to the fourth plus 1 to the negative 1/2 power. You could rewrite this as a fraction with a square root if you would like. I'm just going to leave it like that. Okay, next one. You're going to have to combine a couple rules together here. So we have tangent as our outer function. So the derivative of tangent is secant squared. Keep the inner function the same for now. And then take the derivative of the inner function, which is a fraction, so we need to remember low d high minus high d low over low. We need to simplify a little bit. So this ends up giving us x plus 1 minus x over x squared. So these two will cancel. So when I write out my final answer, I'm going to have y prime equals 1 over x squared times secant squared of x over x plus 1. We're going to cross this one off. We're going to deal with related rates in another unit. Next one, general power and exponential rules. The derivative of e to the x is e to the x, but then you have to remember to multiply it using the chain rule. Same thing with the power. Multiply by the exponent, subtract 1 from the exponent, then multiply by the derivative. Okay, so a couple examples here. Y prime, outer function has that negative 1/3. So we're going to do negative 1/3 times the inner function to the negative 4/3 power because I'm subtracting 1. So that's my outer function dealing with that part. My inner function is in here. So x squared, derivative is 2x. Derivative of 7x is 7, and then derivative of 2 is 0. You can rearrange this if you want. You can leave it as you want. Remember, the AP exam does not require you to rearrange it. If you chose to, I would write negative 2x plus 7 over 3 times x squared plus 7x plus 2 to the 4/3 power, and you can leave it like that. Okay. For b, our first function, or our outer function, is e to the x. So the derivative of e to the x is e to the x. Then we need to multiply by the derivative of the inner function, which is cosine. So the derivative of cosine is negative sine. And we can rearrange this to make it look a little neater. So we have negative sine of t times e to the cosine of t power. Okay, and you really don't have to arrange that. Just make sure you pull the negative out front so you don't lose it, or it doesn't look like subtraction. Okay, shifting and scaling rule. All you really need to do is you can bring a constant out front if that makes it easier. I am going to go ahead and do the next one. We're going to find the derivative, but notice if I rewrite this, we have a couple things going on here. So to take the derivative of this function, we are going to start with the outside function. So I'm going to do this 1/2 power first. So we're going to multiply it by 1/2, keep the inside function the same, and then subtract 1. And then we're going to multiply by the derivative of the inner function. So the derivative of 1 is 0, so I don't have to worry about that. And then the derivative of this part is 1/2 times x squared plus 1 to the negative 1/2. And then notice that there's actually one more function on the inside there. We're dealing with that one. So the derivative of x squared plus 1 is 2x. We're going to simplify this as much as possible. Notice 1/2 and 2 cancel. So this is really going to be x over 2 times x squared plus 1 to the negative 1/2 times 1 plus x squared plus 1 to the 1/2, all to the negative 1/2. And that would be our final answer. Okay, this one's messy. There's 3 functions there, so just be careful. Last one, calculate the derivative of the sine function as a function of degrees rather than radians. Now to change radians, try that again. To change radians to degrees, we're going to use pi times 180, or pi over 180. I'm going to rephrase that. I did say it backwards. To change degrees to radians, we're going to multiply by pi over 180. So sine of pi over 180x, okay, so that's our degrees there. We're going to take the derivative of this. So the derivative of sine is cosine, and then the derivative of our inner function is pi over 180. Okay, so we really have pi over 180 times cosine of pi over 180. Apologize for the mix-up there. I did say it backwards. Okay, so here's your summary. You need to know the chain rule. Look at your notation there, the power rule, the general exponential rule, and shifting and scaling. Okay, here's your work. If you have any questions, let me know. Have a good day.